So this question asks us how to solve for the combining two electrons for the n equals 3, L equals 1 state. So what I've done is I've written down all the different quantum number combinations you can have for n equals 3 and L equals 1. So let's talk about electron number 1. It could be any of these 6 different states. I can have n and L are both equal to 3 or 1. I can have ML equal to -1, 0, or 1, and MS can be -1/2 or +1/2. So it turns out all the different quantum number combinations you can have are these 6. This is what you worked out in the previous part of the problem. So we know for electron 1 and electron 2, they're in these states and can have these combinations of quantum numbers. But if the Pauli exclusion principle applies, then they can't have the same quantum numbers. So if we have electron number 1 is in our first state, electron number 2 can't be in that same state, so I can have electron number 1 in the one state, and I could have electron number 2 in this state, this state, this state, this state, or this final state down here. But I cannot draw this cross line all the way across. Let's draw that in green. I cannot have this state. Cannot exist because that would disobey the Pauli exclusion principle. I would have 2 electrons in the same state. So to figure out all my combinations, I can count up all these lines and how they combine. So I have how many lines here already? 1, 2, 3, 4, 5. And I can keep drawing my combinations. So if I'm in this state for my first electron, my second electron can be in this state up here. Can't be in the same state, so I can't draw directly across. So that gives me my original 5 plus 6, 7, 8, 9, 10, and I just keep doing that pattern. I'm in the third state. Electron 1 is in the third state, so I'm at 10 different state combinations possible now. So 10, 11, 12. I can't go straight across because they can't be in the same state. Pauli exclusion principle. So I'm at 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. So I have 30 possible states that I can use with the Pauli exclusion principle. That means that I can't use these cross. I can't have both of them in the same state. So that green represents 2 electrons in the same state. Now, if the Pauli exclusion principle does not apply, then I can have all of these green lines. How many green lines do I have? I have 1, 2, 3, 4, 5, 6. So if I'm not going to obey the Pauli exclusion principle, I can have those green horizontal lines, and I have 36 different states.